my name is Gabriel Lopez Lugo. I'm from the University of Puerto Rico at GMiS, and I'll be presenting my poster on optimal deep learning neural network designs. To give a brief introduction, neural networks have been increasing exponentially in application in a variety of fields. However, there's a problem. There's a lack of design principles for creating a model that's both efficient in training time and accurate. To tackle this, we apply a model to drone video object identification. By doing this, we apply the model to a real-world problem while at the same time tuning the model to find the best neural network design. Starting off, we used convolutional neural network architecture. We used VGG16 for its high accuracy and its well-adjusted weights. In Figure 1, you can see VGG16's architecture. It usually has dense layers at the end, but we opted for a flat layer as our model is only trained in classification problem of 2 choices. To train our model, we acquire parking lot images from a drone, and we cut the parking spot images individually so we can feed to the model, and then the model will learn how to identify between an empty and an occupied parking spot. To test it, we use a Python script that would locate the parking spots and then would cut them up and give them to the model so it can make a prediction. In terms of optimization, we reduce the image dimension that VGG16 takes from 224 by 224 down to 48 by 48. The reason why is because of the way the Python script collected the parking spots for the model. They were way too small and could not be resized without resulting in a loss of accuracy. So 48 by 48 was the best option for us. We also decrease our batch size from 32 down to 2. We have a very modest data set. It was on less than 100 images with only 52 training images, and it was giving us very inconsistent results even with pre-processing the images. When we reduced the batch size, the performance increased massively, reaching an approximate of 100% accuracy. Then proceeding to time efficiency, we evaluated different combinations of epochs and convolutional layers that could be trained. For training, we initially had the last 7 convolutional layers be trainable, and we were using 9 epochs. We reduced down to 4 epochs and only the 5 last convolutional layers. We found that convolutional layers have diminishing returns. The more you use, you don't get better results. They simply either stay stuck, but the training time does increase though. So in essence, it's diminishing return. However, we learned that also the best way to optimize which layer to use is to keep the ones with the most parameters. We kept the last layers trainable because they were the ones containing the most parameters for training the model. There were more parameters so they can make calculations. If we trained with the first 5 and with the first 7, it gave us worse results as there was less parameters to make calculations that give a better and more accurate output. We also learned that lower batch sizes for very small data sets like ours is quite useful. It actually improves the accuracy. It should not be applied to every case even though our dataset was quite small. It was only classification of 2. Even though it still increased the accuracy from 89% almost up to 100%. And with all this, we were able to reduce the training time from 18 seconds down to 15 seconds. Thank you very much. Have a great day.